Journal. So my name, as you mentioned, is Andrew Jones. I'm the Manager of Operations and Partnerships at SOSCIP, and I'll introduce Faye in a second as well. Today we're going to talk a little bit and try to provide you with a bit of an introduction of who SOSCIP is, and give you a bit of background about us, talk a little bit of our technical platforms, and try to see if there's any possible synergies of how we can help support your research projects. So as I mentioned, so myself is Andrew, joining on the line as well is Faye Mao. He's our technical lead based in Toronto. He is responsible for all of our computing platforms, and he'll give a bit of a technical side on that as well. There'll be, I think I have an agenda slide. Yeah, so we'll kind of talk a little bit about who we are, what we do, as I said. Faye will dig into the platforms a little bit more. We'll then give a bit more details about how a SOSCIP project is developed and what it looks like, and then provide some case studies just for some examples of how this can be developed. Probably about 40 minutes in terms of the presentation. There'll be an opportunity at the end if there's any questions. If there is questions kind of pressing as we go through, if you are, I guess, able to raise the hand, I won't see it, so I'll need somebody else maybe just to let me know, because the way my screen is sharing. But we're happy to answer questions. We're here to talk about what we do, but also to provide details and let you know if there's any way we can support. So I'll jump in at this point. So a little bit about SOSCIP and just who we are and kind of what we do. So SOSCIP's been around since about 2012. We're an academic R&D consortium that is a member base. So we represent about 14 academic members based across Southern Ontario or Southwestern or Southern Ontario, and we follow that under the FedDev government mandate of being more from Ottawa South. So it's very broad across Ontario. Really, our mandate is to help build and foster innovation by working with industry partners and getting them to engage with the academic community, and not only do that, but also to use and apply new transformative technology, high performance computing, AI, machine learning, new tools and technologies that can help our industry partners, but also provide an opportunity for our educational institutions to develop and train new students in HQP and get them engaged on the research projects. So by doing this, really what SOSCIP does is we support these industry academic collaborative projects. Generally, a project is trying to drive and solve an industry challenge, but then how we do this, we work very closely, and we'll talk a little bit later about this, with the funders, so like an NSERC, OC, and MyTax, for example. But what we do differently is we provide access to computing infrastructure, software, tools, technical support that you'll need to do the research project, and then we partner and work closely with the research funders and government partners that will provide the funding to support the project. So we feel it's very much a package deal, and to be truly supportive in this, we need both parties to come together, and we try to provide the infrastructure and the equipment required to actually complete the research projects. As I say in the bottom slide, so really our projects, and we'll talk a little bit about this later as well, are open to any sector, any discipline, and again, it can be funded by any funding program. So we're very funder agnostic from that perspective. We just want to make sure that there is resources in place to ensure that students engaged in the project are supported for their work on the research project. So as I mentioned, really how SOSCIP does this and what we do, so we provide access to sophisticated computing infrastructure. Faye will give you a bit of a detail on that as well. We have access to software, and as well as all of our platforms are supported by technology experts that are there to help support you as researchers as you're conducting your research projects. On my side, more on the operations side and the partnership side, what we do is we help provide, we work with our industry partners to get access and identify, academic partners to join onto collaborations. We help in building and developing the research projects and helping to support it. We work with government funding programs, and we'll talk a little bit later about some of the joint programs that we have where we can have streamlined access to ensure that you're not only getting the technical support and the computational power, but also the funding that's required to do this. And really our mandate for our government funder that funds us, our mandate is really to try to help support Ontario-based companies and work with our academic community to support them and allow them to commercialize new products, improve business processes, create new jobs, and really build and grow and develop their companies. A little bit about our impact. So as I mentioned, so SOSCIP was initially founded in 2012. The organization's grown over the last couple of years. To this date, we've engaged about 125 different companies across Ontario. About 3/4 or 2/3 of them are generally within the SME category, so small and medium-sized companies. Really, the idea is to help support them and provide access to talent and skills and technology that they wouldn't have. Since that time, we've trained and worked with about 750 students and postdocs at each of our member institutions. And really what we're proud of as well is not only are we engaging the students, but we're having direct engagement with our industry partners in these projects. So we've had about 250 industry personnel directly work on, alongside our students as they engage our platforms and work together to help solve these challenges. We are the first in Canada industry-led, AI and data sciences platform. So really our mandate more recently has been about really supporting and applying technology tools to lead AI. We've done this for about 195 projects, and we've done about a total investment of about $100 million over this time. So I'll pass it over to Faye for a second, and he's able to talk a little bit about the actual computing platforms, and then we'll come back afterwards and talk a bit more about the programming side.
Okay, thank you, Andrew. Welcome, everyone. And let me try if I can control. Can I control that?
I see your mouse. You're able to click.
When I click this.
No. Okay.
No.
I can change the slide from my side then. Yeah.
Okay. All right. So at SOSCIP, we offer 3 different platforms. So the first one is very common, and it's a cloud-based, OpenStack-based cluster. So it's not much different if you compare it with AWS or Google Cloud. It's just a platform that provides you a user-managed virtual machine. So you get fully control of the virtual machine. You can install software, pick up operating system, and it has internet access. So you can do make it as a service if you want to provide your service to other people. And on this cloud machine, because it's user managed, so you get fully control. If you have anything like special security requirement or anything like that, then you can implement by yourself. So another 2 platforms are different than the cloud. It is not a virtual machine. It's a bare metal, like a physical machine, and it is not running as a cloud. It runs like a high performance computing cluster. So it's very similar to the research computing facility here in Canada, if you're familiar with Compute Canada. So it's similar machine that is running with a similar idea. So those 2 platforms, parallelized CPU platform and the GPU platform, they are designed to take in jobs. So that means once you are on the platform, you just submit a job, then there is a scheduler, and then it will pick up your job to run whenever there is an available resource. So those 2 machines are designed for HPC, so it has a faster interconnection than the cloud, and you can run it for the distributed parallel computing purpose. Next slide, please. So first is the cloud platform. Most of our machines on the cloud are CPU-only machine, but we are adding GPU capability now. So currently, we already have 16 NVIDIA T4 GPUs available for use, and we are adding 60 P100 GPU, that's IBM-based system, to the cloud, and we are migrating our current storage to a new self-storage. So on this cloud platform, we have more than 4,000 CPU cores, but we don't have a lot of GPU on this, but we have a separate GPU cluster, so that's our main cluster for GPU-related applications. But you can also do GPU-related stuff on the cloud as well, if that's what you need. Next slide, please. Yeah, cloud is, like I said, is no big difference than other providers. So you can do a lot of things. Most of our users use cloud for doing this real-time data analytics and doing some like small-scale machine learning. And if you want to run some distributed computing platform like running Spark or running Hadoop, and cloud is the place you can go. And also because it's connected to the internet all the time, so you are able to host your own database or doing something, providing software as a service. And because it's highly manageable, so you can define your own firewall, intrusion detection system, and do some cybersecurity related application. Next slide, please. And another big advantage for the cloud is that because IBM is our partner and IBM offer some IBM analytics software for free for commercial use. Well, during the project period, of course. And if your program requires other commercial software, and this is also the platform that you can use to run, as long as your commercial software supports Intel CPU and Linux system. So as long as they support those, and you are able to run on the other cloud platform. So because it is a cloud-based cluster, so it doesn't have like a high-speed InfiniBand networking. You will be limited. Well, if you run distributed job, you will be limited to only a few nodes, like create your own small cluster. If you really need to scale to many nodes, then we have the HPC platform there that you can use. Next slide, please. Okay, so let's move to the HPC. We have a parallel CPU platform. It is hosted at University of Toronto. It's actually physically attached to Niagara supercomputer, if you're already familiar with SciNet. So SOSCIP purchased some additional nodes and attached to Niagara. So our user will be able to use Niagara with SOSCIP allocation. So our allocation is equivalent to around 3,000 cores. And this allocation will give all SOSCIP users, SOSCIP projects, a relatively higher priority on Niagara supercomputer than default normal users. So Niagara has, Niagara has like 80,000 cores in total, and each node is using Intel Skylake or Cascade Lake generation of CPU, which is the current generation. And with a clock speed 2.4 gigahertz, and we got 192 raw RAM, and all the nodes are connected using InfiniBand EDR with Dragonfly Plus topology. So this will provide you the capability of running, like scale up your job to hundreds of thousands of nodes. So each of the nodes will provide around 3 teraflops double precision. Next slide, please. And because we don't have a large allocation on this Niagara CPU only platform, so we kind of limit what you can do on this. Usually we only accept application and usage on this platform if you cannot run it on the cloud or on the GPU. So typically people doing this quantum chemistry and the computational fluid dynamics, they are running simulation on this platform because that doesn't run very well on the GPU, or it has to be scaled in multiple nodes, so you cannot get a high efficient on the CPU platform. Next slide, please. Yeah, so this platform is only available for people who cannot use GPU and who has to run this distributed computing task. Next slide, please. Okay, so here we have our, I would say our main cluster. So it's called a MIST, and it's a joint cluster with SciNet, University of Toronto. So this is an IBM-based GPU system. It's similar to the GPU system that people has in the United States, large supercomputer center, Oak Range. So it's similar type of machine. It's based on IBM Power 9 CPU with NVIDIA V100 GPUs. So there are in total 216 V100 GPUs. SOSCIP owns 70% of the system. So our allocation on this system is roughly 150 GPUs. This will give SOSCIP user a much higher priority than default SINET users. So each of these IBM AC922 nodes has 4 GPU, and there are NVLinks between CPU and the GPU. So it's different than the Intel system that you only have NVLink between GPUs. But on this system, you have NVLink between CPU and the GPU, which will give you some possibility of doing large amount of data passing from the CPU RAM to the GPU RAM. And in total, this system, it's roughly around 2.3 petaflops single precision. But because it's a V100 architecture that has a tensor core, like NVIDIA tensor cores. So if you use tensor cores for doing this half precision or mixed precision, then you get around 18 petaflops for the whole system. So the storage is shared with parallelized CPU storage, which is IBM GPFS file system. So it's parallel file system. It's more than 100 gigabytes per second throughput. And network is same as our parallelized CPU platform, which is InfiniBand EDR. Okay, next slide, please. Yeah, on the GPU platform, you can do a lot of things. Most of the people doing machine learning, deep learning, that's what it is good at. And the people also run scientific simulation. Well, most of our users who run scientific computation is for doing molecular dynamics. That's what you can get a huge advantage running on GPU comparing to running on the CPU. Next slide, please. Yeah, so the GPU is, if your program runs on the GPU and it gives you a reasonable speed up, then you should run on the GPU. So it's basically for those programs doing a lot of floating point computations, matrix multiplications, vector operations, that kind of work, including deep learning, machine learning. They are all very suitable for running on the GPU platform. Next slide, please. Okay, so access and support. Well, I already mentioned that the GPU platform and the CPU platform, they are sharing the same storage because they are physically in the same location, which is the SINET University of Toronto data center. But our cloud system is located in a different place. It's actually at Western University data center. So we run like two separate platforms with a different way how you get access. So on the cloud platform, because it's OpenStack based, so we give you a fancy looking white portal, so you can just click and run. And it's a self-serve system. So you log into the system and you just pick up how many CPU cores you want to have for a virtual machine and what kind of operating system. Then you launch a virtual machine and you get a fully access through the SSH, or you're using a GUI like a remote desktop or VNC to connect. Next slide, please. Yeah, but for parallelized CPU and the GPU platform, because it's not cloud-based, it's just a bare metal Linux system. So you need to get a SINET account, which is different account than the cloud, and you submit your job to the scheduler. And we also provide interactive development nodes that you can run your job interactively, but most of your significant job should be submitted as a batch job. And the support is provided by the SINET team at the University of Toronto. Next slide, please. Yeah, SOSCIP technical team. So they includes the technical lead, which is myself, and I provide technical strategies and also project consultation. So before you submit your project, and I can talk with you about how SOSCIP can help you, which platform you need to go, and how much resource do you need. And I also lead the specialist, which we have systemings and the platform specialist. So systeming taking care of the system, and the platform specialist will provide you hands-on support. And also we will provide you training sessions and help you with the software usage and software installations. And we also have site leader, which is for U of T and the Western, and manage the site and also provide the technology strategy for the SOSCIP infrastructure. Okay, next slide. I think that's the last one. Yeah,
great.
Okay,
thanks,
back
Faye.
to you, Andrew.
Perfect. So I'll talk a little bit more about the project's detail side, and just kind of building on the part Faye was talking about. So more from as projects get developed, SOSCIP, really for us, our mandate is to really support, as I mentioned, industry and academic partners across Ontario. So we generally try to have, broad focus areas that we're working within. We give some examples on the screen here. We're not limited to these by any means, but I would say a lot of the uptake that we see within our projects, very much around, advanced manufacturing, health, analytics these days, aerospace, defense, digital media, and whatnot. So, these are the areas that I would say we see a lot of uptake, but we're not limited to these focus areas. Really, so as projects get developed, really, how can we ensure success? So, really we feel, and as we show in the diagram on the right here, the students, the postdocs, the trainees are really at the core of all SOSCIP projects. They really are the opportunity that works, and the vehicle that works between the academic and the industry partner, and generally are the ones that are conducting, the actual research on these. So as projects are getting developed, really what we want to ensure that there's a need, really, kind of like a big data, AI, data science type need for a larger computing powers that can help support your projects. Generally, there needs to be an industry challenge or an industry question that we're looking at supporting, that the academic partner would come on and the team would support and work towards this. Ideally, we would like to see a bit of a commercialization potential. This on the industry partner side, though, this is, ideally they can take the research that is developed during this project and move it to market, or help them improve processes, or allow them to mobilize, the outputs of the research. Not a requirement, but definitely it's what we like to see. Also even from the academic standpoint, the advancement of knowledge, the ability to publish or move the state forward as well. We're very supportive of that, and hope that we can see that come out of our projects. And really, at the end of the day, it is very much about a collaboration. So we want to bring together both our academic and our industry partners together, and really be focused on supporting students and postdocs in a training opportunity, while also working to help solve this industry challenge. How SOSCIP can help support this, so as we mentioned before, so really ultimately we will be providing you access to our computing platform, so we'll help you advance the research. What we do earlier, before we get to that point as well, is really we'll work with you as you're developing your proposal. Faye and the technical team can sit down with you and ensure that your proposal will make the best use of our systems, and ensure that it's not only that it will work on our system, but we can ensure that we are able to support it from a technology standpoint. I'll talk a little bit in the next slide about what happens next, but really the proposals are reviewed by experts in the HPC field. Really what we'll do is, after approval, is we're providing access to this infrastructure that is all based in Ontario, as Faye said. And really what we do is, once the project gets kicked off, it's that ongoing technical and project support for the duration of the project. So really, just to kind of summarize that in another way as well. So really what we're looking to do is have that defined challenge where an industry partner is working with you, the academic teams comes together. We can help in building the project at scope. We work with many projects where maybe there's already an existing relationship and we can come on and provide additional computing power to allow you to accelerate your project and move it forward quicker. And I'll talk about it, I think, on the next slide, but on this one, it really, we will look to leverage any funding contributions that the industry partner is able to put in. So we work very closely with the government funding programs to find a way to ensure that the support is there to advance the research project. And really what we're looking at, in the core project itself is getting the teams onto the platforms, using the technology to allow them to advance the research, and ultimately leading to not only training opportunities for students and postdocs, but also having actual project outcomes come out of the individual research projects. So the process itself, very much, I think step one is where we are now, like, getting engaged, trying to learn a bit about us and let us know you're interested. We always say, we are always happy to have a discussion and determine, if there's a fit, if there's a way that we can help support, from a technology side, excuse me, from a project development side. We have a team of partnerships officers that are deployed across the province. I am physically based in Ottawa myself, so generally I'm the first point of contact for, for the Ottawa U, and even for Carleton if we have any visitors online today from there. And really what we're trying to do is help work with you and help better tell explain what our systems can do and ensure that there's a good alignment and good opportunity that we can help support it. At that point, we kind of work with you to help, ensure that you're defining the project. We do have an application process, and I'll talk about that in a second, but really we work with you for the duration as you're developing the proposal. We'll review it. We'll ensure that the technology request is appropriate and that we can help support it. Faye can give additional suggestions and help on the strategy side, as he mentioned before. Really, it is a non-competitive process, I would say, at SOSCIP. So we're not looking to, when we do adjudicate proposals, we're not looking to screen out or reject. We're just wanting to make sure that they are quality proposals, and that, as I mentioned on point number 3 here, is very much we're looking at, eligibility, suitability, what the technology request is, and what are the scientific and commercial merits of it. So we have a scientific advisory committee that is a representative of each of our member institutions. So for Ottawa U, for example, it's Carlisle Adams as our SAC member. They sit on a committee that meets once a month that adjudicates new proposals as they're submitted. The committee does meet once a month, so generally there's never, from time of submission to outcome, is never more than a few weeks to 4 weeks, I would say, at the absolute most, if you just happen to miss the previous committee meeting. And what we can do is we really strive to have a quick and efficient review of the proposals and get back to you either with feedback or full approval. As I've mentioned before, we really try to work closely with our research funding programs. Over the years, we've had joint programs in place with NSERC. We completed one last year that ran for about the year before that with OC, that was very much supporting postdocs with the Talent Edge program. Most recently, we've had a large number of success working very closely with the MyTax Accelerate program. So this is actually to the point where we have a joint review process, so it can be a single point of application, single entryway to get access to both MyTax funding for the Accelerate program as well as SOSCIP. We do this by MyTax will honor our peer review system. So what we can do is a researcher would apply to SOSCIP. We would then have a form that would join onto that application that would be for the MyTax Accelerate. We complete our adjudication, and then it's just an administrative approval on the MyTax side after the fact. Really what we can do also in this is in what we've launched about 2 months ago. So we're still piloting, but we are going to go to full moving forward with this, is actually the reverse of this now. So if you already have, say, a MyTax Accelerate in place and you're realizing there's a need to add additional computing power on, SOSCIP will accept MyTax peer review process. And what we do is we just look at the proposal as a truncated proposal, just looking at specifically what are the computing needs and how are the milestones going to be aligned to that for the duration. And we can again get those approved very quickly and get them up and running. And this really falls under anything related to MyTax, the Accelerate program. So for startups on campus, if you're under the entrepreneurship program, we can work with that. MyTax is launched, I think this week or last week, the new industry PDF proposal, I think until the end of November. So if you're looking at supporting a postdoc onto a research project with a commercial partner and you have the need to add on computing, definitely reach out to us, because we do have joint application processes for all of these programs so really to streamline and make it as efficient as possible for our researchers. And then after approvals are in place, really it's implementation. So this is where you get more handed over to Faye and his team, and they'll provide really that hands-on assistance and training to get the teams onto the platforms, get them up and running. If there's any technical challenges, they're your first point of contact that will work with you and help. And really what we want to ensure that all of our teams are fully supported from time of application through to onboarding onto the platforms through to the project completion, that there is a team on our side that are here with you the entire time, that if you need any assistance, if you need help or support, we are here, and we are, to help manage your project. And really, we're wanting to ensure your project success through the duration. So really kind of why SOSCIP? So as we mentioned at the onset, so we are really one of Canada's only R&D consortium that's really focused on providing access to high performance and advanced research computing tools for industry academic collaborations. So really what we want to ensure is, as we've said, it's not only ensuring that there's funding for the projects by working with our funders, but also that you have the tools and the technology that you need to complete the research. As I said, we have the full hands-on support for not only the partnership development side and application process, but also on the technical side. Really it's, the value of these platforms can range, we're providing access anywhere from, we feel, between $10,000 to $100,000, depending on the platform and the duration and the scales. When someone applies to SOSCIP as well, you have access to all of our platforms. So as Faye talked about the different systems, maybe someone's interested only in the cloud, but maybe somebody sees a need for both clouds and GPUs and maybe even parallel CPU systems. So really we scale the needs of the project, or the computing platforms based off the needs of the project, and you're not limited to any one platform. You do have access to all of our technologies as part of a proposal to SOSCIP.
Sorry.
Yes. Yep. Yeah.
You seem to be spotlighted somehow. We put the slides to the background. Did you spotlight yourself? Or? Oh yeah. Okay. Thank you.
I haven't touched anything. Can you still see?
Yeah, I can see the slides.
Okay, perfect. I only see my screen, so I don't. Unfortunately, I don't see anything else.
There was also a question in the chat while I'm talking
perfect.
anyway.
Okay.
So
excellent.
David Knox asking, what is the proposal format, and where and how do I get the template?
Yeah, so we used to have it on our website. I think we were just doing some updates to it, but I'm happy to email it to anybody. I mean, if you're interested, you can either just contact me directly and I can send it to you, or we can share it after this proposal as well. It follows similar format, I would say, to a MyTax NSERC type proposal, very much just defining the research challenge, talking about how the technology will help support it, the key milestones that are going to be accomplished during it, what is the training component for students that are going to be engaged in the project, a bit about how a company could help commercialize, or what are going to be the commercial potentials of the project at the end of the day. We ask a little bit about EDI, and if there's an approach or a strategy that's going to be taken to this, and then very much just it's a bit of a discussion about the participation of the industry partner. And that's where we see quite a bit of variety. We have some of our projects where maybe the industry partner doesn't have in-house technical expertise, and this is where the student and the academic researcher are able to come on and really build on that and provide that support. We have other examples where we support projects where maybe the commercial partner has a fully, a team in place, so they're actually able to help support and build onto it, and both are completely acceptable from our side. And then that gets adjudicated by our advisory committee every month. So we're happy to share the template at any point, and I think we'll be having it on our website as well again soon. I'll continue at this point, but by all means, if anybody else has any questions, let me know.
There are actually some questions in the chat.
Sorry. Yeah, unfortunately, I'm not able to see the chat. So
yeah, no, I'll just read them out.
Okay, perfect.
So Laura Muno has two questions. Can you speak about the user fees and IP agreements?
Absolutely. So I'll do IP agreements first. So really, SOSCIP takes no stance on IP. In the past, there was, so IBM is a partner of the consortium, and in the past, there was greater involvement, I would say, of IBM at the project level. Starting in 2019, really each of our projects are governed by what we call a project collaboration agreement, a PCA. Really, the IP agreements are left to be defined by the parties of the project, so the academic and the industry partner. Really, what we're finding for all of our projects recently is there's normally, and not in all cases, but in many cases, there's already an existing IP agreement in place between the university and the industry partner, and we will piggyback off that arrangement. We don't need anything additional to that. But really, what we in the absence of it, I think the baseline position is normally background stays with who developed it. Foreground is shared. However, we take no formal position on that, and we really default either to the university policy on IP ownership, or to whatever agreement that's been worked out between the researcher and the industry partner. In terms of project fees, so we do have a one-time access fee for SOSCIP projects. It's $2,500 per year, and that gets prorated. So if you're looking at a short-term engagement, so a 6-month project would be $1,250, and then if you're looking at a longer-term duration, really this is just it's a step-in fee to ensure that we can get our projects in our platforms up and running. It's the same fee whether it is one of our platforms or all of our platforms. So we really encourage our project teams to look at all of the computing needs that we can help support for it, and then this gives you the continued technical support for the duration of the project as well.
Okay, thanks. And there's another question from David Knox again. What is the approval process turnaround time typically?
Yeah, so lately, so the advisory committee, I think, as I mentioned, meets once a month. Normally, we know within a couple of days after that the outcome. Generally, as I said, it's a non-competitive review. So the outcomes are normally, I would say, 95+% approval ratings. But what we are seeing a bit more, sometimes the advisory committee will come back and just asking for some clarifications, just a little bit of an update to the proposal. And once we can get those clarified, we go to full approval. So we see, so from time of the meeting, we see approvals happen within days to maybe about a week or so afterwards, depends on how quick. Normally, once we can get, we would go back, if there was some clarifications request, normally we would go back to the applicant and they can just provide it by email, and then we can get approvals done very quickly afterwards. So from time, if we look at approval times from date of the advisory meeting, normally everything within, it could be days to about, maybe a couple of weeks at the most. And then that committee meets every month. Normally about mid-month is when they meet. So we can time submissions. A lot of our proposals come in generally the week before the meeting. People are conscious of maybe the times for that. And we say normally the meeting is about mid-month. Each month, and then that way, I think our next one is going to be November 13th. So we would need proposals about a week before that to give us time for them to be reviewed by our committee members, and then we can have a response to the applicants about a week after the meeting.
All right, thanks. That's all the questions in the chat for now.
Yeah, and I think we're almost done on the slide, so I'll just finish up, and then if there's any other questions. So, as we mentioned before, IBM has been a partner of SOSCIP since its inception, and really the big thing that they provide to our teams at this point is access to software. So if there is any need for any of the IBM software for commercial purposes, we have access to a catalog and are able to support that. And then, as I said before, also, at the platform level, they are all staffed by technical support that can help work with our researchers. So we just have a couple examples just to kind of give a bit of perspective of maybe what a SOSCIP project looks like. And then there'll be lots of time for questions after that as well. So I think in these examples, I've picked some to try to show a variety of different types of projects and really, the application of how this could work. So this first one is with Unilever Canada, that was with Ottawa U. So this is actually within the Telfer Business School. And really what it was looking at was trying to create modeling around trade promotion. So the backstory to this project as well is Unilever had approached us and they were looking for opportunities to work with the academic researchers, and they had several challenges that they were needing support with. So we worked with them in defining what the challenge was. We then reached into our academic members, and this is where it led to Ottawa U. And we sat down, we provided the introductions and helped build the partnership and build it up from the inception. Really, this was an idea where Unilever had massive amounts of data related not only to their sales, but also, promotions at their retailers that they work with. And they wanted to be able to use this for more, forecasting, modeling, and start really take a deeper dive into the data and to be able to use it more for better modeling for promotional materials. So they access our cloud and our GPU platforms in this. And really what the idea was is how could you pull in, financial data, publicly available data like from StatsCan, weather data, starting to look at competitor pricing and behavior and models, and how can they better say, in one example they sometimes gave was, how can we know on Mother's Day weekend in May, if the weather's nice, are we going to sell more of our Breyers ice cream versus our Magnum ice cream, and really starting to pull a lot of the data sources that were available and dive deeper into this. So it's led to some carry-on projects with Unilever, and really started to build a stronger relation for them in SOSCIP as a consortium member, but also really being able to work with our academic partners on this. Another one with Faculty of Engineering again at RU was with APX. Really, this was starting to look at how we can start using IoT and creating more intelligent data related to floor plans, and within as emergency responders are going into buildings, is having better understanding of situational awareness and location-based information within an environment that they're not used to. So really, this was tapping into our cloud analytics program platform, and really started to better able to create smart floor plans for buildings and have better tracking mechanisms. So as first responders were moving throughout, they would have better location-based services, so that would provide a more efficient and safer environment as they're trying to move through a bit. A building on that perspective. And this was a project that was funded in partner with OCE through the Talent Edge program. So this was more of a postdoc focused, developed and led project that spanned for about 2 years. Just to kind of give one non-Ottawa U example, so this was one with grain farmers in Ontario working with the University of Guelph, and really trying to dig more into RNA sequencing data and get better understanding of how we can use this on our cloud platform to start looking at more resistance markers, and start ultimately try to improve crop breeding processes, and have more improved disease resistance, and ultimately try to create a better product that would span from multiple commercial providers. So this is where an organization, Green Farmers in Ontario, as a nonprofit, saw an opportunity to work on behalf of the industry, and really to drive a project that getting more into genomics type of data, and build into this a little bit. I think this is one of the last ones we'll show. So this was, again, with Ottawa U, with chemistry department, OTI Lumionics. This was a relationship that was already in place between the partner and the university. And really what it was, how could SOSCIP come on and provide additional computational power to help them advance, as they were starting to look at, designing new materials for OLED. Really, this was a really exciting relationship because the industry partner was driving more of the computational side, whereas the chemistry, the university was actually able to take some of the simulations and the materials that were proposed and actually test these and try them out. And it was a great relationship between the two parties that was actually able to start to develop and test new materials that could be used, and that would be better in the manufacturing process for designing new OLEDs. And really just one last one. I chose this one just because I wanted to show an example where we can bring multiple partners together as well. And I think that's really the case for any of these projects. It can be a single relationship between one academic and one industry partner. We can bring teams together, so multiple schools coming together, or even multiple partners. This is an example where it was with Carleton and the Ottawa Hospital came together, working on a joint proposal that was funded through IBM Canada and CIMVHR. CIMVHR is based out of Kingston. It's the Canadian Institute of Veterans and Mental Health Research. Really, the idea was, how can we start applying and bringing in new, machine learning and AI tools, and tapping into our GPU and our cloud systems with working with the rehab center at the Ottawa Hospital. So as we're looking at patients that are suffering from, traumatic brain injury or PTSD, how can we start taking more of a rehabilitation approach and start using, tools and technologies to have better real-time understanding of the system, how we're, trying to come up with better training plans and ultimately better treatment plans to maximize the rehabilitation benefit. So this was an opportunity where it brought together multiple parties, both on the academic side, but also on more the industrial side, that came together at a common need. And we're both using not only facilities at the Ottawa Hospital and the rehab center, but also at Carleton. So I'll leave it at that. Really, I'm open. If there's any questions, we're happy to discuss. Really, what we're just trying to showcase today is, SOSCIP, we've recently invested into these 3 new platforms. They've come online this past winter, and I think some of even the GPUs in the cloud are just coming on over the summer, as well as with our new cloud infrastructure. We performed about a $6 million update to our platforms. So all of our platforms are, as Faye mentioned, very leading technologies that are available to our researchers. Our goal here is to help support you as you're working and engaging with industry or nonprofit partners, if there's ways that we can help support the research project as well as provide technology to help support it, that's really our goal and our mandate, and really to ensure the success of the research. So, Jono, I'm not sure if there was any other questions for either Faye or myself at this time.
Not in the chat, but okay. If anybody feels free, you can type in the chat or you can unmute yourself and ask. Oh, I see Tom who is raising his hand. So go ahead, Tom.
Yeah, thank you for the presentation, both of you. I had a question. So this only works for Ontario-based companies. Is that how it works?
Generally, so our funder is FedDev Ontario, so their mandate is to support Ontario-based companies. Really, as long as generally the position is if this company has a location in Ontario, it doesn't have to be their primary office, but if we are able to look at supporting a regional footprint, if they're not based in Ontario, and we have had examples in the past where this past summer. We had a call for proposals around supporting COVID-related projects, and we were able to support about 24 projects. So we did have a little bit more flexibility in that and working with a few partners outside of Ontario. So generally speaking, it is, our main requirement is for them to be located in Ontario, but sometimes we do have a little bit of flexibility on a case-by-case basis.
Okay, so I guess, so we're working with Total, a French oil and gas company, and I guess we had approached Vitax, so we are, and they were quite enthusiastic about supporting this project. They were saying, yeah, well, it's not a Canadian company, but the IP will stay in Canada, and you're funding postdocs and stuff that are Canadian. So I don't know if that would qualify, or that's something that you would have to look at on a case-by-case basis.
Yeah, so generally we would have to look at it as a case by case. If one of the funders is able to support it, sometimes that also opens up additional opportunities for us. I mean, this is definitely maybe worth a discussion offline we can have, okay. And we can dig into it a little bit our side as well. Sometimes if there's multiple partners, or if there's another partner joining on, or a nonprofit that's engaged, if it's just a straight relationship with yourself and the French-based location, I mean, definitely we would have to take, I'm happy to have a discussion offline about how we could try to see if we could support that. We have worked with Total in the past on another project based, I think, with the University of Toronto. At that time, there was there was a Canadian-based partner as part of the project as well. So that simplified it maybe from our perspective. But I'm happy to have that discussion offline as well.
Okay. All right. I guess I'll contact you if I can see a way forward then.
Okay. Excellent.
Thanks.
Thank you.
Okay, there's one more question from David Knox. Thank you very much for your presentations. I would appreciate getting a link to your site which clarifies the user fees and the details of the application process. So, is it in your slide somewhere? Yeah. Okay.
Our site's being revamped in certain areas, so I think currently the application isn't on it. What I'm happy to do is I can share it by email afterwards. I can forward it to you, Journal, if you want, and we can share it. I'm also happy to, as I said before, share a copy of these slides, and we're happy to give the breakdown of any of the fees as well.
Okay, excellent. Thank you. So, any more questions? Because I have one question too. Okay, so yeah, you said you were bringing on VMs that have GPUs in them. Is it like a dedicated GPU, or is that a shared GPU? Like, would multiple VMs use the same GPU?
For now, we are providing dedicated GPU, but we're looking to get it virtualized. NVIDIA has the technology that will allow you to run multiple virtual machines on the GPU. That's something we can look at in the future. But for now, because the GPU only has 16 gigabytes of memory, if we continue virtualize it, so each of the VM will only have like a 4 gig or 8 gig, that may not be sufficient enough for many people.
Right.
So as a start, we provide the whole GPUs, just a PCIe device pass through. So it's not virtualized, running multiple virtual machines. But that's something we are looking to in the future. Another problem is that our technology only works with x86. So our P100 GPU cannot use that technology because NVIDIA just doesn't support that on the IBM machine. So yeah, we don't have a lot of T4s. So, maybe we're looking to that. But for now, it's not virtualized in the way that you describe. It's passed through the device. It's a whole GPU that's available for one single VM.
Okay, thank you. And that actually brings me to my next question. So this is all Power 9, right? So do you have trouble with some closed software running on that? Because most are designed for like x86, like MATLAB, for instance. Do they support Power 9?
No, MATLAB that you have to go to the cloud, and they don't support Power. So you have to run it on x86. But open source software, like people running machine learning, PyTorch, TensorFlow, all kinds of that, it's run very well on the Power. But we do see some software not running very well, but that's just corner cases. If you do machine learning, deep learning, I would say most of the software will just run.
Okay, great, thank you. So are there any other questions?
Yeah, could I just ask about how much, and maybe I missed it, but it's a technical question about how much disk space, storage space there is available.
If you go to cloud, and at least we provide 8 terabytes for each project. But if you need more storage and you can apply, we will check if that's a reasonable application and if we have storage space. We had some project asking for like 10 terabytes or 20 terabytes, and shouldn't be a problem. And on the GPU and the parallelized CPU platform, we provide each project 100 terabytes, like a scratch space. So each people has 25 terabytes quota. So if you need more, we can provide you more. But that type of storage is different than the cloud. There is a purge policy for the scratch storage, but there is a way that you can just avoid the purging, so you can store as long as you want. But this capacity-wise, it's 25 terabytes per person and 100 terabytes per project. If you need more, definitely we can look into that and provide you more space.
Okay, thanks.
Okay, anybody else? Going once, going twice.
Well, as I said before, we're happy to share the slides. We're happy to we can include a copy of the application just if people want to take a look at it and see better. Either Faye or myself, we have the contact information in the slides. You'll have it as well. It's on our website. If anybody has any questions, we're always happy to have a discussion. And yeah, please don't hesitate to reach out to us at any point.
Okay, well, thank you very much, Andrew and Faye, for that presentation. I'll put the recording up as soon as I can, and after you send me the slides, I'll forward them to everyone.
Excellent.
So thanks again, and talk to you later.
Great. Thank you, everyone.
Bye-bye.
Thanks.
Take care.
Bye.